That's about 10 minutes into the show, and I think we've got our announcements. Anybody in particular got any kind of announcements that they want to share? I'll open it up one more moment here for anybody who wants to announce anything. No? Ed's shaking his head. No? Hey, we got Greg Pugh joining us from GP Animations. Hey, Greg. Okay, well, I'll tell you what. Let's go ahead and get into today's topic then. Let's talk about Vertex shaders. So, Stephen, tell us what was important about last week's conversation, and what do we need to know for this week?
Okay, so in general, a shader is a program that manipulates some graphical element. It's a programmatic way of producing some piece of your image. So a fragment shader will, given, say, a texture position and a texture, you can put together a color at a given pixel. And usually it'll be something simple, but you can go complex. We also showed the playground, which is a way that you can make fragment shaders in Corona. Or not in Corona. You can test them in your browser, and they're almost ready to go in Corona. A vertex shader takes a vertex, which is your position, texture coordinates, color, and something called vertex user data. So it's the pieces of your geometry, essentially. If you have a rect from display new rect, it's the four corners. If you have a circle, it's a bunch of little points that approximate the circle. What other shapes are there? Polygon, it's the endpoints. And then you can do something to them. So the default vertex shader leaves them unchanged. Now, but I have got an example that I will show.
So last week we were saying that you could manipulate pixels, right? So that you could programmatically create an effect. Then you could have the fragment, which you were saying was you're taking a texture and then doing something to it, and then the vertex is a step up from that. Is that what we're saying? Now we're full on doing something with shaders.
Right. You don't, strictly speaking, need a texture or a fragment, but in the end, you get a pixel. A vertex shader takes the content coordinates of a display object, and it lets you do something with those. If you do nothing, they just pass through unchanged. But you can move the points around. You can move the texture coordinates. You can slide those. I believe those are the only parameters that are exposed to you in Corona. Those four.
Okay.
And I think the simulator doesn't really show up as a window, right?
Well, yeah. If you're trying to share, you've got you can either share your whole desktop or you can share a particular window.
I'll do that.
But don't forget to hide your
Yeah, go ahead and hide your browsers. That way,
hide your browser before you share your window. But then it's hard to do because
Sorry.
you're doing both at the same time.
Yeah.
Yeah, this program feels like it's missing some fast toggle between. Are you seeing this?
Yeah, we see some text.
A wavy line of text? Okay, so this is an example of a vertex shader. I started with, this doesn't show very well, but can you see that at all?
It looks like a white text on a white background.
Okay, it is. So this, what object do you think this is under the hood?
New text object?
Rectangle.
Any other guesses?
Snapshot.
Okay. This is a new polygon.
Huh.
So I'm taking, and I can show this without fill. So it's just a polygon.
It's a rectangle.
It is. It's a rectangular polygon. And the reason I do that is because that lets me make a bunch of points, which are a bunch of vertices. So there's 20 on the top and 20 on the bottom. Okay?
Okay.
And I use an typical paint with an effect. And this is the effect. It's a vertex. It has a vertex shader. It's dependent on time, so that's how we get the wave. When we set is time dependent in our kernel, we'll get this value filled in, corona total time. That's a measure of the seconds that have passed in the program. So it's an input that's changing every frame. And we can feed it to functions like here, sine. I have x. We'll go ahead and x. Okay, x. In the vertex shader, you can also get the texture coordinates. So they'll, in a normal object like a rect, which doesn't have any frames or any.
Can you visualize all the vertices?
You want to see them? All right.
Yeah, I definitely think that would help to know where they're being, because you're saying there's 20 on the top and 20 on the bottom. It'd be good to know what they look like.
Let's see what I can do.
Can you make us some balloon animals?
Yeah, whoops. I cannot make you any balloon animals. I do not have any balloons. That's not very.
So are these 20 points? Are they along the I don't know if that's the right term, but they're on the outside of the.
They're all on the top and all on the bottom.
Okay, so they're okay.
On the top, I used a sine function to displace some of them, so they're evenly spaced from left to right.
Gotcha.
So every so often there's another point, and it forms the rim of the polygon.
These are basically stripes, right? Vertical stripes.
Right. Oh, what do you mean by stripes?
Well, narrow rectangles from top to bottom. Columns.
Yes, the relevant point is that you have a bunch of points, because if you only have 4, actually I'll show you.
Yeah, well, I think what Sergey may be asking is, are those 20 points along the very top of the rectangle and the other 20 points are along the very bottom of the rectangle, or are they a series of rows?
There are 20 going from left to right, and it goes down here, and 20 right to left. So here we go from left to right, just x, and increment by 30 pixels each time. And we go backwards on the bottom.
Okay.
So far, so good. Now, those get passed. Each of those 40 points gets passed to the vertex shader, more or less simultaneously. So some of them might be processing at the same time, because they don't depend on one another, the vertices. So the graphics card it doesn't need to worry about them clashing with each other, so it can do several at once. And this parallelism is what makes shaders fast. That's why you can do a whole screen of pixels with a program on H1, for example. So
okay.
We take the sine using the time and our left to right position, and this gives us some value. We scale it, and add it to the position. The position is what we get from the vertex.